In this problem, we're given an object and its weight when it's on the surface of the Earth. We're going to take that object, we're going to raise it to a new altitude, an altitude that's 3 times the radius of the Earth. What would be that object's weight at this new location? So when we talk about the weight of an object at the Earth's surface, we know that the weight here on the Earth's surface, we calculate that as being m times g, the mass of the object times 9.8 meters per second squared. So we're saying that's what we have right here, 856 newtons. But now we're going to move this object to a new location where its altitude is 3 times the radius of the Earth. So its altitude's measured from the Earth's surface. Now, what we have to factor in is the fact that, well, the Earth itself already has a radius of, well, the radius of the Earth. So our total distance right here is really 4 times the radius of the Earth. When you're talking about the force of gravity, you're always measuring from the center of your object. And Newton's law of universal gravitation tells us that the force of gravity is the universal gravitational constant times the mass of your two objects. In this case, it would be this object itself, and the Earth, divided by the distance squared. And here's what we want to focus on, is we're changing this distance. We're saying when the distance was only 1 times the Earth's radius, we had this weight. Now our distance is becoming 4 times greater. And so what's that going to do to the force of gravity? Well, if you take your radius here and you make it 4 times greater, and that's being squared, these other units are still here, they don't change. Well, 4 squared is 16. I'm going to pull that 16 out here to the front. And so the force of gravity, what we're saying is when you make the distance 4 times greater, the force of gravity becomes 16 times less. So if we had a force of 856 newtons while on the Earth's surface, now we have a distance that's 4 times greater. The force of gravity is 16 times weaker. And so this would be 53.5 newtons.